Okay, here we go. I want to carry on with section 10.1 and do a couple more questions. I want to do question 6, but it says this. It says copy this table of values for x plus 2y equals 9. Essentially, here's the equation, x plus 2y equals 9, and the table goes 0, 1, blank. Well, I don't want to do that because it says draw the graph of x plus 2y equals 9 for values of x of 0 to 9. In other words, I will work out all the coordinates for all the x values, so like this. And remember, the y we're going to work out in a minute. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So they give us such a short table to work with. I'm not going to do that. Just do that. Oops, a bit ugly that. Now look, a little bit tricky this. If we're going to substitute a 0 in there, we've got 0 plus 2y equals 9, and therefore the y is going to be, what's it going to be? It's going to be 9 divided by 2, it's going to be 4.5. So I've created the coordinates 0, there's the 0 there, and 4.5. Alright, a little bit tricky. I think I better just do one of these. A bit easier just to go right across there like that, and make it tidier. Alright. Alright, so that's a bit more complicated, isn't it? I won't necessarily plot the graph because I know you can all plot coordinates like 0, 4.5. It's not difficult. So now substituting the 1 in the x value, x plus 2y makes 9. Therefore, what you do, you take the 1 away from the 9, so you've got 2y equals 8, and y is going to be therefore 8 divided by 2, which is 4. I've got the point 1, 4. Looks like it's going down in halves, doesn't it? Here I'm going to substitute the 2 in the x value, so 2 plus 2y equals 9. Again, take away the 9, and that will give us y equals 9 take away 2 is 7, so 7 divided by 2, 3.5. And I've got the value 2 and 3.5. Okay, here's the trend going down in 3.5s. Just do one more with 3. So I'll put x equals 3, so 3 plus 2y equals 9. So 9 take away 3, I've got 2y equals 6. We'll just show you that one. So y equals 3. I've created the point 3, 3, and I'll just keep going like that, and I can just plot the line. So that's as far as I want to do with question 6. It's I did question 5 very thoroughly, and one had a positive gradient and the other had a negative gradient, and so there's nothing more to show you here other than that if you get equations with the x's and the y's on the left hand side, you've got to be able to handle it quite happily. Now let me just rule that off a little bit, because it says I've got to, in the other question I've got to, this is question 6, sorry, question 7, complete this table for values of x minus 2y equals 1. In other words, it's negative now. Never mind, I'm not going to complete the table, but I will do some calculations. I've got to go from minus 3 up to 3. So minus 3, minus 2, minus 1, 0, 1, 2, 3. Don't know if I'm going to do all of these. Let's just do a couple anyway. Bring it over here, go red. So if I do that, it might separate it off a little bit, mightn't it? It's not beautiful, but you get the idea. And that'll do. We'll have one here, so that's the x values, and I'll label it as such now. So these are the x values here, and now I've got to work out the y value. I'm giving myself a little bit of space to do the calculation. So if I'm going to substitute minus 3 into that x value, I'm going to go minus 3 minus 2y equals 1. So what we're going to do is take the 3 over and plus it, so we've got minus 2y equals 1 plus 3, that's 4. And now we just divide by minus 2. So y equals 4 divided by minus 2, minus 2. I've therefore created the points minus 3, minus 2. So that was the original x value, minus 3, and the y value is minus 2. I'll do a couple more. It's a little complicated. It's like having to solve an equation every single time you substitute a new x value in. So that's what I'm going to do. I'm going to put minus 2 in the x there, minus 2 minus 2y equals 1, because that's the equation. So minus 2y is going to be 1 plus 2, it's negative there, take over and plus it, that's 3. Therefore my y is going to be 3 divided by minus 2, minus 1.5. I've created the point minus 2, minus 1.5. As you can see, we're going up in halves. Let's try it one more time. Minus 1 minus 2y equals 1. Putting the minus 1 in the x value there. So I've got minus 2y equals 1 plus 1, because it's a negative 1 on this side. Take it over and add it. 1 plus 1 is 2. Therefore, y is going to be 2 divided by minus 2, minus 1. So I've got minus 1, minus 1. Just one more with a 0. Nothing. Take away 2y equals 1. So minus 2y equals 1. No point taking the 0 over and adding or taking away. It doesn't make sense. So now I simply divide 1 by minus 2, and I get minus a half. I've created the point 0, minus a half. So, and again, I'll just keep going like that. And that's what you have to do. You've got to be able to handle these, either do them mentally or do them on paper. If you're in an exam, ask for spare paper in order to do this, because there may not be enough space to do all this thinking out loud, so to speak. You've got to think quietly anyway. But what I'm saying is, if you need something to write on, don't fill up the exam paper with lots of scribbly little coordinates which you can't decipher yourself, let alone the examiner. Right, I want to do question 8 because it's totally different to what we've done at the moment. It wants you to identify which of these are straight line graphs. Now, you may recall from Key Stage 3 that the general equation of a straight line graph is y equals mx plus c. Well, that's the gradient, the steepness, it's the number in front of the x, and the c is the y-intercept. Now, what does that mean? Well, if I've got, say, a pair of axes like so, and I draw a line like that, I can calculate the gradient of the line. I think this is beyond grade C, but anyway, it's an indication of the steepness of the line, but the intercept is that point just there, and it will be 0 something, alright? So it will be 0, call it y generically, because that's the y-axis there, isn't it? And that's the x-axis. So a straight line graph will have a y in it and an x in it. It will not have an x squared or a 1 over x or anything like that. It will just be y equals something x plus something, and that's a straight line graph. So have a look at this one. I've got y equals 1 minus 5x minus 8x, sorry, that's question 8, first graph. Is that a straight line? Yes, it is. It's a straight line graph. We have a gradient of minus 8 and it's a single x, and it crosses at the point 0, 1. How about this one? 2y equals 5x plus 4. Yes, it is a straight line. Even though it says 2y equals 5x plus 4, I can arrange it in the form of y equals 2.5 x's plus 2. What did I do? I divided everything by 2 to get a single y on this side, therefore everything must be divided by 2 on the other side as well. And here we go, we have a gradient of 2.5, a single x there, it's not squared or cubed or anything, and it crosses at the point 0, 2. Next one, I've got y equals x squared plus 7. That is definitely not a straight line graph because it's x squared. Alright? In fact, x squared graphs, if you were to plot them, look a little bit like that, you know, so they're U-shaped graphs, generally speaking, and they can occur in all sorts of positions on the graph paper. But don't worry about it. For now, it's x squared, it's not linear, it is not a straight line. And finally, we got 4x plus 3y equals 8. Well, that's going to be linear or straight lined as well, for the simple reason it's not based on x squared or 1 over x or x cubed. I could rearrange that, but that will look very, very messy on paper, and I don't want to confuse you by trying to rearrange that at foundation level. I'm not doing that. Turning over to question 9, it's got a little star by it. Well, that means you have to think about it, but it does deserve your attention though. I've seen these come up in Unit 2 papers. Which of these points lies on the line 3x plus 2y equals 12? Now, they've given me a point 0, 4. Does this lie on the line? Well, this is what we do. If we put the 0 in the x position, because that's the x coordinate, and the 4 in the y position, because that's the y coordinate, if the sum works out to be 12, then this coordinate belongs to that equation and therefore sits on the line. Let's try it. Back to black. I've got 3 times 0 plus 2 times 4. 3 times 0 is 0, and 2 times 4 is 8. That equals 8. Well, 8 is not equal to 12, therefore the coordinate 0, 4 is not on the line. Now I'm not going to do all these because I've been given 6 of them. I think I'll pick another one, 3, 2. So let me rewrite the equation again. 3x plus 2y equals 12. I'm testing the point 3, 2. In other words, put the 3 in the x and the 2 in the y. Let's do some sums. 3 lots of 3 plus 2 lots of 2. See what it comes to. Well, 3 3s are 9, 2 2s are 4. That comes to 13. Well, 13 does not equal 12, therefore 3 2 is not on the line. Be nice to find one. But anyway, when you do, you should get the answer of 12. Let's do the very last one, and I'll turn over, and I assume it's the hardest part. So here we go again. 3x add on to 2y should come to 12, and I'm testing the coordinates -2, 8. So here I go. You go in there, and you go in there. Right. 3 lots of -2 plus 2 lots of 8. Let's see what we get then. Right, 3 times -2 is -6, plus 2 8s are 16, -6 plus 16 is 10. Oops. 10 is not equal to 12. Very disappointing. I haven't found one yet. Therefore, -2, 8 is not on the line. Nice to have found one. Let's just do one more, otherwise I'm going to start getting really upset here. Let's just try this one. If this scores, I'll be happy and I'll stop the video, and that will be I'm talking. I should shut up and finish off the question, shouldn't I? I'm testing the point 6 minus 3. You go in there, you go in there. We're going to test you out. Right, 3 lots of 6 and 2 lots of -3. Right, 3 6s, 18. 2 times -3 always -6, and 18 minus 6 is 12. Oh, that deserves to be underlined. Lovely shiny little star there. Yes. Conclude. Let's change colour. So yes, bang. 6 minus 3, look like a proper yes, is on the line. 3x plus 2 equals 12. Answer, because 12 equals 12, and we've landed it. I'm going to stop there, and I'm happy with that. I'm going to prepare for 10.2 quite soon.